Okay, so one last point to make here. I keep talking about relative fitness, so in terms of contribution that the individual makes to the gene pool of the next generation. That last statement on the slide, selection favors certain genotypes by acting on the phenotypes of certain organisms. You have to keep in mind that selection can't just act upon a single allele, it acts on the whole package, the entire organism that lives in a place. So it's really acting directly on the phenotype, and the genotypes are what are obviously a part of that. So if you think about things like, you read about gene maps that you determined how far alleles are apart from each other, say on a particular chromosome. If you have two alleles very close to each other in a chromosome, one may be beneficial, one may be less so. But because they're so close together, that less advantageous allele is going to be a hitchhiker with the one that is helpful, that is advantageous. So you have to keep in mind that sometimes you might say, well, how come you see these traits? Well, they might be close together enough that selection is favoring a certain allele and another one happens to be along for the ride. Okay, so moving on to the next slide. So the next section is talking about three modes of selection. Okay, so we've established natural selection is important, but how does it work exactly? Well, natural selection can change the frequency distribution of heritable traits. It can change the frequency of alleles in a population in three ways, depending on how the phenotypes in a population are favored. The three forms of selection are directional selection, disruptive selection, and stabilizing selection. The first, directional selection, favors individuals at one end of a phenotypic range. So you'll see that frequency curve for the particular phenotypic characters move in one direction or another. So you might see this in situations where a population's environment changes, or when members of a population migrate to a new and different habitat. And something we're seeing right now is observing what's happening to polar bears. As we are losing a lot of the elements of their normal habitat, some are migrating, some are staying in place and having to adapt to the new conditions. So unfortunately, we may get to watch some of this happening in real time. The second form, disruptive selection, favors individuals at both extremes of a phenotypic range. The third type is stabilizing selection, and it favors intermediate variants acting against extreme phenotypes that would be at the ends of the phenotypic range. So looking at these mice in this illustration, the uppermost illustration shows the full range of phenotypes for this particular mouse. Okay, everything from a very light color to a relatively dark color. So the phenotype we're looking at here is fur color. The frequency of individuals is what you're seeing on the y-axis. So the original population has the most individuals in that center, in that sort of average between the two extremes phenotype. And we look at three different ways in which selection can change that phenotype ratio that from the original population. So if you look down to the left, directional selection, what's being favored are phenotypes that are towards one end of that range. So from that original range, what you see in this illustration is ones with darker fur color are being favored. So over time, you'd go from that original population, you'd come back generations later, you'd see the evolved population would have basically a new most common phenotype, and that would be again towards the darker range. So directional takes you in one direction or another. In the center illustration, you see disruptive selection. So that form that you see in the middle is the one that's not the best fit to that environment. So you'd see disruptive selection taking out the middle, leaving the extremes at both ends, so the very light colored and the very dark colored mice. The last one is stabilizing selection, where the extremes are not favored. So the very light and the very dark mice are not favored, but the ones in the middle are. So you see that frequency of individuals with that type increase in the center, decreasing on the sides. I'm just going to pop through these illustrations here. Okay, so the key role of natural selection is to change the frequencies of alleles, to increase the frequencies of alleles that enhance survival and reproduction. So what's happening as a result of natural selection, any one of those types you see there, is adaptive evolution. You're seeing, say in those mice you saw in the last slide, you're seeing the form of mice that works best, is the best fit to that environment, increasing in numbers. So you're increasing the frequency of alleles that enhance the survival, that enhance leaving more offspring to the next generation. So you see this adaptive evolution occurring as that match between the organism and the environment increases, as there's a progressively better fit. And they give you a couple of examples here in illustrations in your book. Things such as the fact that cuttlefish, if you look at the top illustration, if you look closely, you can see what looks like a little octopus or a little squid, actually. And it's so well camouflaged, right? You can barely see this guy when he's holding still. Okay, so the ability to change colors and to perceive the environment and be able to have not only the ability to change colors, but the ability to detect the environment and make the colors match the environment. Cuttlefish and many other octopods, octopus-like animals have some of these have phenomenal ability to change colors. That's a whole nother thing. If you stick around for 122, we'll be getting into that. Anyway, the next illustration down shows the fact that snakes have very movable, very mobile bones that allow for things such as disarticulation. If you look at that bottom photograph, you see an egg-eating snake, and it can totally disarticulate both the lower from the upper jaws and the halves of both the upper and lower jaws from each other. So it allows the snake to be able to engulf, to eat food much larger around than its mouth would otherwise allow. So and again, these are just things you can see with the naked eye. There's all sorts of adaptations out there. And again, these tend to arise gradually over time as natural selection increases the frequency of alleles that form traits that enhance survival and reproduction. So again, as the number of individuals with those favorable traits increases, you're getting a better match of an organism to the environment. So something to keep in mind is, okay, you can, over long periods of time, you can see this beautiful fit developing. But what happens if then the environment changes, right? So the world changes, environments change. So sometimes what works best may have to change as well. So say where that little squid lives, if they say that the environment, the substrate, the surfaces on which it's resting change radically. If it doesn't have the flexibility to be able to match those areas. Okay, time for a pause.